All right, so we're going to keep moving along, and now we're up to problem number 25. And it says a basketball player hits 3-point shots 43% of the time. If she takes 4 shots, so here I go with my blanks that I like to put in. What's the probability that she misses the first shot? So let's write down here a little miss. And then she hits the last 3 shots, so hit, hit, hit. All right, so let's start with the easy part. The hitting part, it says is 43%, so I can put a 0.43 in each of these that say it's a hit. But then the opposite, which would be a miss, so I want to do 1 minus 0.43, which is 0.57, and I want to put that in the first one. So now we need to multiply these together. So I have 0.57 times 0.43 times 0.43 times 0.43, and I got 0.0453, actually 1899. I'm looking at the results that I have up there to choose from. You can see it was rounded to a percent, so it's going to move over twice. So now it looks like 4.53%, and then my choices I have here, 4.5%, that would be it. All right. 26. 2 marbles are drawn without replacement, that's important, no replacement, from a box with 3 white, 2 green, 2 red, and 1 blue marble. Find the probability that both are white. Okay, so when we start off, let's start with 3 plus 2 plus 2 plus 1. So 3 plus 2 plus 2 plus 1, that says there were 8 marbles altogether, so that's where we want to start. So the first time when we draw a white, there were 3 choices and out of 8. Now our assumption is the first one we got was white. That's the only way we're going to be able to get 2 white ones. So the next time there's 2 that are left that are white out of 7 marbles altogether. So on the top, 3 times 2 is 6, and then on the bottom, 8 times 7 is 56. Those are both even, so I can reduce that to 3 over 28, which is A. So move that up. 27. If a single fair die is rolled, find the probability of getting, sorry, I talked real bad right there. Find the probability of a 4 given the number rolled is odd. Well, that's not possible at all. If the number is odd, it can't be a 4. So not a trick question, just making sure that we have the right thing. Okay, so let's change that scenario, 28. If a single fair die is rolled, find the probability of getting a 5 given the number rolled is odd. Okay, so definitely this is possible. I can get a 5 if I know the number rolled is odd. So what you're looking here, now that I've told you something ahead of time, like I know that the number is odd, so when I'm looking at my choices 1, 2, 3, 4, 5, 6, the 1, the 3, and the 5 are odd. Okay, so there's one way, 5, out of those 3 ways of getting a 5 if I already know that the number is odd. So it increases the probability that the number is a 5. Like if I had just rolled and there were 6 choices, it would be 1 out of 6, but because I gave that extra information that I got an odd number, it makes it a little easier to get a 5. 29 says 2 marbles are drawn, again without replacement, from a box with 3 white, 2 green, 2 red, and 1 blue. This is the scenario we had earlier. Find the probability the second is red given the first is white. Okay, so I'm going to write second red given first was white. So when we're looking, we're back to 3, 4, 5, 6, 7, 8 marbles all together. But we're assuming that they've already drawn one, so there are 7 left. The first one was white, so it tells me it wasn't red, so there were still 2 red ones left in there. So that's D. Don't overthink these. Kind of slow it down and think, what are they asking me for? So the only thing you're getting out of that first draw that we got a white one, I have 1 less marble, so I went from 8 to 7. They didn't take any of the red ones, so I have both of them to choose from. The second part says, what if they were both red? Okay, so the first time there were 8, and the second time there were 7. The first time there were 2 reds, the second time there was 1. I have 2 over 56, which reduces to 1 over 28. Okay, let's move it down. All right, up to number 31. The following table indicates the preference for different types of soft drinks by age groups. If a person is selected at random, find the probability that the person drinks root beer given that they are over 40. So now I only want to look at these people that are over 40, which when you look at it, I have 20 plus 30 plus 35. This says there were 85 people in the survey that were over 40. But then we particularly care, like, do they drink root beer? So that's 30 over 85. You can definitely reduce both of those numbers. So maybe you want to do a two-step reduction. Maybe the first time you see 30 and 85 both divisible by 5, so you make this a 6, and then go 85 divided by 5, and that gives you 17, and then you go, oh, I'm done. Right? So sometimes you have the question, does anything else go into it? Do what looks obvious, and then you'll be able to tell if there's more reduction later. So there's our answer to 31. 32 is just making sure you understand some of the new terminology that I've given you this semester. So this one just says, what is 6 factorial? Hopefully you know how to put this in your calculator and you found the button you're supposed to use. If not, make sure you go look it up on YouTube and you're ready to go for the test. So 6 factorial is 720. You can, of course, go 6 times 5 times 4 times 3 times 2 times 1. I think that takes too long. Don't do it. Same thing for number 33. I'm making sure you know how to just find a permutation without having the application built into it. So again, I'm hoping you know how to do this on your calculator. So I'm pushing 9 in my calculator, going to my permutation button, saying I would like to select 3, and it tells me there's 504 ways of doing that. Okay, let's get into application. How many 3-digit numbers can be formed with the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 if repetition of digits are allowed? Okay, so a 3-digit number, it's important to think about a 3-digit number. It can't start in a 0 because then that's 2 digits, like however old you are, and I'm sure all of you are 2 digits. It's not like we say we're a 3-digit number like we're 0, 2, 1 if you're 21. So when I'm looking at the 3 choices, all right, so now that we have our 3 choices, we just restricted that first one to say the first one, there's only 9 choices since I can't use a 0, but the other ones have 10. So when I do 9 times 10 times 10, I get 900. 35 says, how many ways can 7 people be chosen and arranged in a straight line? That's an important part, arranged in a straight line, if there are 9 people from whom to choose. So I have 9 choices, and I'm going to choose 7, but this arranged in a straight line says that's a permutation. So let's make that 9 permutation 7. Big number, 181,440. 36. License plates are made using 2 letters, 2 blanks, letter, letter, followed by 2 digits, so 2 blanks, digit, digit. How many license plates can be made if repetition of letters and digits is allowed? Okay, so there are 26 letters, and because I'm allowed to repeat them, I have 26 in each one. And then there are 10 digits, and again, I'm allowed to repeat them, so I have 10 in each one. So 26 times 26 times 10 times 10 says 67,600. 37. How many 4-letter radio station call letters can be made? So 1, 2, 3, 4. If the first one must be a K or a W, which means 2 choices, repeats are allowed, but the call letters cannot end in an O. Okay, so this one is not an O, so that means there's 25 choices, but the ones here could be anything we want. So I have 2 times 26 times 26 times 25. That says 33,800, which is A. 38, back to just making sure we know how to do a combination. So we want to put in our calculator 8 combination 4. That's 70. 39, how many ways can a committee of 3 be selected from a club with 12 members? So committees is a key word. Committees are always combinations. So I'm going to do 12 combination 3. Says 220. 40. How many ways can a student work 7 of 10 questions on an exam? So I have 10 things and I'm picking 7. So now when you're trying to decide is this a combination or a permutation, you think, well, would it matter what order they answer the question in? And the answer is no, it doesn't matter what order you use them in, it just matters that you did 7 questions. So this is 10 and we want to pick 7. And that says 120. The last one for this video. A bag contains 7 apples and 5 oranges. If you select 6 pieces of fruit without looking, how many ways can you get 6 apples? Okay. So anytime we're looking at probability, and this is not probability, sorry about that. So anytime we're looking at this, we need to look at what are we trying to do? So we're trying to get 6 apples. So we notice there are 7 apples, and we're trying to get 6. Now, since the apples are apples, you're not going to really be able to tell them apart. So you say it doesn't matter, order doesn't matter, you're just getting to 6 of 7 apples. So I say 7, and I go to do a combination, and then it says 6, and it says there are 7 ways to do that, so that would be my answer. All right, so that's the end of this part. Come back and I'll have another section. I'll probably just go ahead and finish the rest on the next video.